All right. So there is this work I'll go forward that I received. Someone just forwarded to me. So let's say in this case you are given different moles, well, different uh, vapor pressure. So notice that this is mole fraction of benzene, and this is mole fraction of methylbenzene. So notice that by the time you do one these two, it gives you one. Do this, 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 it gives you one. So in this case, let's say they've given you partial pressure of benzene, and then the partial pressure of methyl benzene. That is the uh, vapor pressure. So in this case, you don't need to employ this formula again. So that means it has already been solved for you. All you just need to do is to find the P total. So to find the P total is simply now the sentence saying all you got to do is just come and do this zero. Let me remove this because we've seen that everything here must add up to 1. So all you got to do is 0 plus 1.12. So everything here, if you check it, everything here for each case adds up to 1. So we don't need to look at mole fraction, just this vapor pressure plus this. So when you add these two up, it gives you P total. So the next one is 0.9 times if you add this up, this gives you 1.12 times 10 raised to the power 4. So then we have the next one times 10 raised to the power 4. Then we have 0.84 times 10 raised to the power 4. So all you have to do is just add it up. So when you do 0.9 times 10 raised to power 4 plus 0.84 times 10 raised to power 4. So you have 17,400, which is the same as 1.7 times 10 raised to power 4. So we'll move to the next one. 1.8 times 10 raised to power 4. Then we have 0.56 times 10 raised to power 4. So you know information is power. So just in case you got this question and you got the other one, because I received the two questions, so let's solve for the two. So we have 1.8 times 10 raised to 4 plus 0.56 times 10 raised to power 4. You have 23,600. So 2.36 times 10 234 raised to power 4. So let's move to the next one. So we have 2.7 times 10 raised to power 4, and then we have 0.28 times 10 raised to power 4. So we just add up 2. Remember we said that P total, Dalton's law of partial pressure. By the time you add up the individual partial pressures or the individual pressures, it gives you the total pressure. So that's what we are doing. Everywhere. So don't worry. So 2.7 times 10 raised to power 4 plus 0.28 times 10 raised to power 4. This gives me 29,800, which is 2.98 times 10 raised to power 4. So I have the next one, 3.6 times 10 raised to power 4 plus 0. It's the same thing as saying 3.6 times 10 raised to power 4. So this is my total pressure. This is my total pressure. So all I got to do is, when I'm now solving for uh what's it called, the vapor pressure of the benzene and that of the methyl, I use this and this, then against each of these. So the way we plotted the first one. So you don't really have business with the total pressure looking at it, but you just have to know it, because what you use for your graph is just these two, then and this one as well. You have to do it in such a way just as it is. So see it now, the way it is in this setup, moving this way, and then moving this way. That's how you plot your graph.